Hi everyone, this is Spring 2020 CS61B Midterm 1, and I'm going to be walking through question 1. Let's begin by reading the problem statement. Given two one-dimensional arrays LL and UR, fill in the program on the next page to insert the elements of LL into the lower left triangle of a square two-dimensional array S, and UR into the upper right triangle of S, without modifying elements along the main diagonal of S. You can assume LL and UR both contain at least enough elements to fill their respective triangles. Okay, so reading the problem statement, admittedly it is very confusing, so let's look at the example and hopefully that'll clear things up. For example, consider LL is this long array, UR is another long array, and then S is an empty 5x5 array of zeros. After calling this function that we're supposed to implement, we see that the entries of... Okay. Should be on writing mode. Perfect. The entries of LL go respectively in the lower left triangle of S. Likewise, we can see the entries of UR go in the upper right triangle of S. And the order in which they're inserted matches in the direction of the array. So you see, it goes 11, 12, 13, 14. We see here it goes 11, 12, 13, 14. Then we start the next row, 15, 16, 17, 18, 19, 20. Okay. So it kind of makes sense what the problem is asking. So let's see what the skeleton code is that's provided. So we're going to go to the next page now. Okay. Fill in the lower left triangle of S with elements of LL and the upper right triangle of S with elements of UR. Okay. Assumes that S is square and LL and UR have at least sufficient elements. Okay, so a bit of information that was repeated before. And then let's see what the skeleton code gives us. We see we have int n, which is the length of S, right? And S is square, so it's also the number of columns and the number of rows. And then we see here they give us two variables, KL and KR, right? We don't really know what they do yet, perfectly fine. Intuitively, we can see that KL probably will correspond to some variable tracking progress of LL, KR will probably track some progress of UR, right? We don't really know what it does yet, and that's perfectly fine. So, we're also given this for loop, where we're iterating from I equals 0 to n, and we're incrementing I by 1 each time. Okay, understanding the problem statement, understanding the skeleton given, let's try to think of some logic behind this problem. So, I drew a couple arrays on this right-hand side, and let's go back. So, we're given, what was it called? LL, okay, I need to move to this screen. LL is 1, 2, all the way up till 10. And then UR is going to be 11, 12, all the way up till 20. Okay, and we're going to put it in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then UR will go 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. That makes sense. This problem is very tricky, so immediately the solution may not come. So let's keep probing a little further to see if we see any patterns. So what do we know about multidimensional arrays? Well, we know we can iterate through a multidimensional array using a nested for loop, right? What we can do is we can iterate through the rows, then iterate through the columns. Okay? This is probably something you guys have seen before, maybe in Signpost, right? At each point, now we're going to extract a certain square, right? So we'll look at a current square. So we're going to start off, we can kind of highlight the progress of our iteration. We'll start off here, then we'll go like such, and eventually, using this iteration technique, we'll go through any given array, right? And this is something you guys have seen before. Let's see if we can kind of use this idea to help fill in the array S to what it should be, right? We will start right here. Since it's a diagonal, we don't do anything, right? Let's put that down. Given any square, right? If square is diagonal, right, along the diagonal, don't do anything. right? Then we can move to 11, right? And now we see here that 11 is in the upper right corner, or upper right triangle, so we can insert the next element from UR, right? Which is 11. So we insert the next element of UR, and then we probably want to move some counter to 12, right? And this is maybe what KR is going to be used for, right? KR might be the counter to say which element of UR we're currently on. Likewise for KL and LL. Okay, that makes a lot of sense. Let's keep playing around with this idea. So, if the square is in upper left triangle, we'll call that ULT. I'll write that here. ULT is upper left triangle. Oh gosh, I can't spell. Right? And square is in ULT. We're going to do two things. The first one we're going to do is we're going to insert next element of UR. Then we're going to increment counter. Right? And then we keep iterating through this, right? We'll go to 12, 13, 14, all follows the same logic. Then we get to 1, we see it's the same situation as before. If the square is in the lower left triangle, we insert the next element of, let's use this color randomly, of LL, then we increment, right, this KL, the LL counter, okay? So we can write that down just to be rigorous. If square is in lower left triangle, right, LLT is lower left. Oh gosh, triangle kills me every time. Triangle. Okay. That's okay. Okay. If it's in the lower left triangle, what we can do is we can insert next element of LL, right? And we're going to increment counter. Let's be more specific, counter of UR, counter of UL, right? Okay, now we have some idea of some pseudocode. The last thing we need to figure out is how do we know if a square is in the upper left triangle, and how do we know if a square is in the lower left triangle, right? Let's look at a given matrix, a given square, right? How do we know that this is in the lower left triangle, right? Let's look at the coordinates ij. This corresponds to 2, 1, right? Let's look at some other points in the lower left triangle. Right here, this corresponds to 4, 1, or 4, 0, right? So we see here that I is strictly greater than j for all of the entries in the lower left triangle. And by symmetry, we can also see in the upper right triangle, I is going to be less than j, right? This example will be 0, 2. So that's a really cool idea. And finally, if we can plug in an I and j check here, we can figure out if the square is in the upper left triangle or the lower left triangle. Okay, now that we figured out the logic, let's translate it into actual code. So we wanted to do a nested for loop for this line right here, this one more specifically. So let's go to the code. For int j is equal to 0, j is less than n, j plus equals 1. Right? Each time, we're going to look at I and j, right? If I is, if I is greater than j, that means we're going to insert into the lower left triangle. So let's add that in here. Okay, actually, I want to be consistent with the solutions, so let's do the other case. If I is less than j, right, that's the other other case, if we're in the upper right triangle, then we can simply set that position in the square to be the corresponding condition in the upper right. And we can increment our upper right counter KR. Perfect. And then the other situation follows by symmetry, else if I is greater than j, right? All we're doing is we're going to that spot in the square, we're setting it equal to the value of the lower left array indexed at KL. I apologize for the handwriting. And then we increment our KL counter by 1. Yep, this is the solution for the first question. Thank you for paying attention.